Okay, so now that you've seen a few more examples of solving the systems of linear equations using just starting with the equations and then solving from there, just kind of having the technique down. And also, I think in the other video I put a few applications as well. But let's do a couple of different kinds of applications, see how we create these systems of linear equations and then go about to solve them. So let's take a problem that's pretty similar to a lot of the problems on your homework. Let's assume that you go to a concession stand, for example. Let's say the concession stand has burgers and french fries, and maybe you make 2 trips over the course of a couple of days, but you don't bother looking at how much an individual burger costs or an individual fry costs, but you do know what the total is after buying a certain amount. So let's say that on trip 1, you go through and you buy 3 hamburgers and 2 fries. Okay, and your total ends up being $10.75. But again, we haven't bothered to check and see how much they individually cost. So on trip 2, we're going to make a similar purchase, except for now we're going to buy 2 hamburgers and 4 orders of french fries. And this time the order comes out to be $12.50. Okay, so the question is, knowing just this amount of information, how many of these we bought and the total of our orders, can we figure out just from what we have, how much the individual burger and individual french fries cost? Well, what we need to do first is, of course, define a variable, define 2 variables in this case. So we want to go ahead and define, in this case, I'll let x be the cost of a hamburger, so price of a hamburger. And then I'll let y be the price per fry. Okay, so the price per french fries. Well, we know that if we bought 3 burgers and 2 fries and it added up to be $10.75, then we should be able to take 3 times the price of a burger, add that to 2 times the price of a fry, and we should equal 10.75. So that gives us actually our first equation. So 3 times x plus 2 times y is equal to 10.75. Likewise here, if I bought 2 burgers and 4 fries, the number of burgers times the price per burger, so 2 times x, plus the number of fries times the price per fry, 4 times y, that should come out to be $12.50. So that gives me my second equation. So 2x plus 4y is equal to $12.50. This is probably the most complicated part in terms of what we have to think about, because the rest of this is just solving this system of equations like we've been doing in the previous problems. So let's solve this, and I'll try not to erase too much here. Maybe I'll just move this information. So. So that way we have our information, we have our variables still listed over here. So we'll start with my system. So 3x plus 2y is equal to 10.75. 2x plus 4y is equal to 12.50. And then we just need to solve this system of equations. So it would be really easy to eliminate the x variable or the y variable. In this case, they're both about the same. I could turn this to a 6 and this to a negative 6, and then I could knock out the x's using the elimination method. So I'll take my top equation and just multiply everything through by 2, and my bottom equation I'll multiply everything through by negative 3, because I'm trying to make this 6 and this a negative 6. If I do this, this top equation becomes 6x plus 4y is equal to 21.50. And then the bottom equation should become negative 6x minus 12y is equal to 12 times 3 is going to be 36, and then this will be $1.50, so it should be 37.50. But it will be negative. Okay, now I can add everything straight down, so 6 minus 6 goes to 0, that cancels out. 4 minus 12 will be a minus 8. And then this will be 21 minus 37. I can really think 37.5 minus 21.5. So that's going to leave me with 16, but it will be a negative 16. Then I can divide by negative 8. Now we get y is equal to 2. So that tells me that my fries should be $2 a piece. Now be careful, make sure your answer makes sense. If I solve through and I've got like a negative number, then that doesn't make sense to have a negative price on something. So then you can go through and you can check your algebra. So now that I have the y value, I can simply plug this back into one of my original equations. It doesn't really matter which one. Maybe I'll just take the top equation. And I'll plug in 2 for y. So here I'll replace the y with a 2. And I get 3x plus 2 times 2 is equal to $10.75. Now I have an equation that only has an x in it, so I'll just need to solve for that. Let me move this podium in case it's in the way. So 3x plus 4 is equal to 10.75. Subtract a 4 from both sides. I get that 3x is equal to 6.75. And then if I divide this by 3, 3 goes into 6 twice, and then goes into 0.75, 0.25 times. So I end up getting x is equal to 2.25. So a hamburger costs $2.25. An individual French fry costs $2. And we get that simply with the information that we had before, just knowing what the combined totals were, and then working backwards, or working through the system of equations to figure out what the individual values are. So another problem that's very similar to what you have in your homework is a problem that deals with interest rates. And I did one like this in class, but this will give you another example. So let's say that we invest a total of $6,000 in 2 accounts. Okay. The 2 accounts, one has interest rates. So one has an interest rate of 2%, and the other has an interest rate of 1.5%. And then we received a total of $97.50 in interest. Okay. So if that's the case, the question becomes, how much do we invest in each account? $6,000 total, so how much of each do we invest in each individual account? The 2% account and the 1.5% account. So again, we need to start by defining our variables. So in this case, I can let x be, the way we figure out what the variables should be is we just ask ourselves a question: what are we trying to solve for? What are we trying to find in the problem? In this particular problem, we're trying to find how much I invested at 2% and how much I invested at 1.5%. So that's what I can just use for my variables. My first variable will be the amount invested at 2%. And then my second variable, y, will just be the amount invested at 1.5%. Okay? And so then we have our variables. Now in this particular case, I have one easy equation and then one equation that I have to think about a little more. First off, if I know that there's an amount that I invested at 2% and an amount that I invested at 1.5%, if I add these two amounts together, it better equal to $6,000 because that's what I was initially told in the problem. So I know that if I take x plus y, it better end up equaling to $6,000 since those are the two amounts that I invested. Now I also know that my interest from these individual accounts added up to be $97.50. So if I know that there's a certain amount sitting in the 2% account, I know that it accrued 2% interest. So if I actually take 2% and multiply it times x, that should be the amount of interest from account 1. So this is the amount of interest from the 2% account, 0.02 times x. Likewise, I know that the amount of money that I put into the second account is represented by y. It grew with 1.5% interest, which would be 0.015. That would be the interest, and then times the amount that's in there. So this will be the amount of interest. Sorry, 0.015 is the percentage rate, the interest rate, and then if I multiply that times y, then I get the interest. So this is the amount of interest from the 1.5% account. If I add both of these together, it should equal my total interest, which was $97.50. And again, if you need to make some labels as you go along when you're setting these up, that's perfectly fine, if it helps you keep everything straight. Because I know the amount of interest from the first account plus the amount of interest from the second account should equal to the total interest made, which is $97.50. And then I have my two equations. So I'll just go ahead and erase this so I have some room to solve this. I'm kind of limited to my space here. I don't like dealing with decimals, so I'm just going to go through and multiply the bottom equation by 100, because that will turn this to a 2, this to a 15, and this will be a large number, but it will be at least a nice whole number. So 97.50. We can knock out either one of these variables, again, using the elimination method. This is going to be a 2x, so maybe I can make this a negative 2x by multiplying the top by negative 2. So now my new equations will be negative 2x minus 2y is equal to 2 times 6,000 is 12,000, so this would be negative 12,000. And then here, 100 times 0.02 is 2, which is what I wanted. 100 times 0.015. And actually, we see a problem here. If I multiply this by 100, I get 1.5y. That's perfectly okay if you don't mind having the 1.5. If you wanted to eliminate all of your decimals, you could have actually multiplied by 1,000. That would move this decimal over 3 places, but then I would have had a 20 here instead of 2, so we would have to multiply this by 20. You can see the numbers start getting rather large. So either way is fine. I don't mind so much dealing with positive 1.5y, especially when I add it to this. I know I'm just going to be left with a negative 0.5 when I do the negative 2 plus 1.5 at the end. Okay, so 100 times 97.5 here is going to be 9,750. If I add these down, the negative 2 and the positive 2 cancel each other out. Negative 2 plus 1 is negative 1/2. So this becomes negative 0.5y. And then here, let's see, to get from 97.50 up to 10,000 would be $250 more dollars. And then up to 12,000 would be another 2,000. So it should be 2,250. So now I'll just divide both sides by negative 0.5. Again, the negatives are important because they're both negative, so when you divide, this side by negative 0.5, it also, this will become positive. Negative divided by a negative is positive. And I'll end up with y being equal to 4,500, okay, which is reasonable because that's within our 6,000. You would know there was a mistake if you tried to solve this and ended up getting a number that was bigger than 6,000, like 8,000. Then all of a sudden you would know you've made an algebra mistake somewhere. And that is the amount that's invested at 1.5%. So I can just remember, again, I'm running out of space a little bit here. I have kind of a small board, but I'll just move it over here. So $4,500 at 1.5%. So this is why it's good to have these defined, because when I get to the end and actually get a number, I actually know what that number stands for. I'm not second guessing myself and knowing the different interest rates. Now, if you know that altogether this had to add up to be 6,000, then you can just do this part in your head. You know that this has to be 1,500. Of course, you could plug it in and solve the equation if the numbers weren't quite so nice, and then you could figure it out like that. So that means that x must be $1,500. So we must have invested 1,500 at 2%. Again, you could go ahead and check this. So we can just see if this percentage comes out to actually equal what we want it to. Well, 1.5% of 4,500. That's just equal to 0.105 times 4,500. And that's equal to 67.5, so $67.50. And then 2% of 1,500, that's $30, because that will be 0.02 times 1,500, which is $30. So if you add these together, sure enough, you end up getting $97.50. So there we go, we checked it, and we know for sure that we got this problem